Hi friends, in previous video we have discussed about rationalization of monomial sets and rationalization of binomial sets, right? So today we are going to discuss about conjugate sets. Okay, conjugate sets. Conjugate sets means what? The binomial sets of the form a plus root b or a minus root b are called conjugate sets. Here each set is the conjugate of other. That means a plus root b is the conjugate of a minus root b. Similarly, a minus root b is the conjugate of a plus root b. Clear? So this is a binomial set, right? Binomial means combination of two monomial sets. So here a plus root b is a binomial set. Whenever you have a plus root b in this form, this is called conjugate set. Okay, suppose with example we will see. Suppose we have one example, 5 plus root 7. Okay, what is the conjugate of this set? 5 plus root 7 conjugate is nothing but 5 minus root 7. Okay, these two are called conjugate sets. Okay, these two are called conjugate sets. 5 plus root 7, 5 minus root 7 are called conjugate sets. Suppose if you do summation of this, 5 plus root 7 plus 5 minus root 7 minus root 7 plus root 7 will cancel. 5 plus 1 you are getting a 10. That is nothing but rational number you are getting. Okay, rational number. Suppose I will do product. Okay, 5 plus root 7 into 5 minus root 7. What you are going to get? A plus b into a minus b is nothing but a square minus b square, right? So 25 minus root 7 whole square means what? 7 only. So are you able to understand? 25 minus 7 how much? 18. Again you are getting what? Rational number. Okay, so you are getting rational number. That means the sum and product of conjugate sets are rational numbers. The sum and product of two conjugate sets will give you a rational number. Okay, remember this thing in your mind. Okay, note also we can take. What is that note? Suppose every conjugate set, okay, every conjugate set is a rationalizing factor, but converse need not be true. Okay, but converse need not be true means what? Means what is the meaning? Let us check. Suppose we will take one example. Okay, suppose we are taking 4 plus root 3. Okay, what is the conjugate of 4 plus root 3? It is 4 minus root 3. Okay, 4 minus root 3. Now this 4 minus root 3 is a rationalizing factor of this 4 plus root 3 or not? That we are going to check. How? Already we have completed the topic of rationalizing factor, right? What we need to do? Just multiply this with this, so that you should get a rational number. If you are getting a rational number, then this is a rationalizing factor, right? So multiply 4 plus root 3 into 4 minus root 3. So again a plus b into a minus b, so a square minus root 3 whole square. What you are going to get? 16 minus 3. 16 minus 3 means 13. 13 is nothing but a rational number or not? It is a rational number. Okay, so if this is a rational number, then 4 minus root 3 is the rationalizing factor of 4 plus root 3 or not? Yes, now it is a 4 minus root 3 is the rationalizing factor of 4 plus root 3. So here now you read the definition. Every conjugate set is a rationalizing factor. Okay, every conjugate set, that means conjugate of 4 plus root 3 is 4 minus root 3. This is the rationalizing factor of this 4 plus root 3. But converse need not be true. What is the meaning of that? Converse need not be true means what? This is not the rationalizing factor of this. Okay, now let us check with one more example. Suppose root 2 plus root 3 I am taking. Okay, root 2 plus root 3, suppose it is a rationalizing factor of root 2 minus root 3 or not, because conjugate of root 2 plus root 3 is root 2 minus root 3, right? So first, now we will check this. Okay, but what you have to do? Just to do plus. Now because of doing into, now you do plus. Instead of doing into, now you try to do plus. What you are going to get? If you do plus root 2 plus root 3, okay, plus root 2 minus root 3, this one will cancel. What you are going to get? you are going to get root 2 plus root 2 is nothing but 2 root 2. Is it a rational number? No, it is not a rational number. Are you able to understand? It is not a rational number. So if it is not a rational number, then root 2 plus root 3 is not a conjugate of root 2 minus root 3. Are you able to understand? Okay, so this is how you have to think. Okay, so first one is 4 plus root 3, 4 minus root 3. If you are multiplying, you are getting a rational number. Suppose here also if you multiply, then you will get a rational number. A plus b into a minus b, a square minus b square, 2 minus 3, right? 2 minus 3, you are going to get 2 minus 3 means you will get minus 1. Minus 1 is a rational number. Yes, it is a rational number. If it is a rational number, then it should be a rationalizing factor, right? Then it should be a rationalizing factor. Okay, so 2 root 2, suppose, that means what is the meaning here? If you are doing summation of these, listen carefully, if you are doing summation of these two, we got 2 root 2. Now what is the meaning of that? 2 root 2 is not a rational number. Okay, 2 root 2 is not a rational number, that's why it is not a conjugate. But if you do multiplication, okay, what you are going to get? 2 minus 3 only, because a square root 2 whole square minus 3 whole square, you are going to get minus 1, which is a rational number. If this is a rational number, then automatically this root 2 plus root 3 is a conjugate of root 2 minus root 3 or not? Yes, it is a conjugate of root 3 minus root 3 only. Are you able to understand? When we are doing product, then it is a conjugate. But when they are asking us to do addition, then when they are asking us to check through addition, then it is not conjugate. Are you able to understand? But by using product, you can simply say that it is a conjugate. Clear? So don't confuse. So simply you remember only one thing. Conjugate means what? Any binomial set which is in the form of a plus root b or a minus root b are called conjugate sets. Okay, this thing you have to remember, which is any binomial set which is in the form of a plus root b or a minus root b are called conjugate sets. Okay, and each is conjugate to other. What is the conjugate of a plus root b? A minus root b. What is the conjugate of a minus root b? A plus root b. Okay, so this thing you just keep in mind. Here this one, 5 plus root 7 conjugate what? 5 minus root 7. Is that clear? 5 minus root 7 is the conjugate. How we checked through multiplication, we got rational number. Okay, that is up to here. Here also same thing, 4 plus root 3. What is the conjugate of this? 4 minus root 3. Here also root 2 plus root 3, but it is not in the form of a plus root b. It is in the form of root a plus root b. Okay, that also you have to check. Now here a plus root b, a minus root b. Clear? Again here doing into, we are getting rational number, so it is a conjugate. But they given one note. What is that note? Every conjugate set is a rationalizing factor. So every conjugate set, now this is a conjugate of this 4 plus root 3 and 4 minus root 3. 4 minus root 3 is a conjugate of 4 plus root 3. Suppose if you are doing calculation, you got a rational number. So if you get a rational number, then this 4 minus root 3 is the rationalizing factor of this 4 plus root 3. I have explained about rationalizing factor in previous videos. Please go and check there. Okay, if you have any doubt regarding rationalizing factor. Okay, similarly here also same thing, but here also what they told, every conjugate set is a rationalizing factor. So this is a conjugate set, it should be a rationalizing factor of this, right? So we got that. If we are multiplying, we got a rational number or not? We got. But converse need not be true. Means what? Suppose converse need not be true means what? Suppose if you are taking any rationalizing factor, okay, now any rationalizing factor you take and you do conjugate of that, it may get a conjugate or it may not get a conjugate. That is what the meaning. Okay, that is what the meaning. How we got that? Suppose you can see here if you do sum also, here also if you do sum, 4 plus root 3 plus 4 minus root 3, what happens? Root 3 will cancel, you are getting 4 plus 4 is 8 means a rational number. Are you able to understand? 8 means a rational number. That means here if you are multiplying also you are getting rational number, if you are adding also you are getting a rational number. That means this 4 minus root 3 is the rationalizing factor of this 4 plus root 3. Okay, now by taking conjugate, already this is a conjugate, we are trying to prove that this conjugate is a rationalizing factor or not. We got the solution that it is a rationalizing factor. Now in this example what we are trying to prove, we are trying to prove reverse. That means we are already taking a rationalizing factor and we are trying to prove whether it is conjugate or not. Are you able to understand? So we are taking a rationalizing factor. What we did, we did sum. If we do multiplication we are getting a rational number, but if we are doing sum we are getting irrational number. We are getting some other number which is not rational, we are getting irrational number. Then if you are not getting rational number here, then how can you say that, this particular root 3 minus or root 2 minus root 3 is a conjugate of root 2 plus root 3? No, right? So that's why root 2 plus root 3 is not a conjugate of root 2 minus root 3. Why? Because we are getting irrational number here. Understood? So this is how you have to check whether, that's why the statement they are given, every conjugate surd is a rationalizing factor only. This is a conjugate surd. If you are doing rationalization, every time we are getting rational number only, but converse need not be true. Means what? We are taking one rationalizing factor, we are taking root 2 plus root 3 as a rationalizing factor of this, but if you are trying to solve we are getting irrational number. That means this is not the conjugate of this one. That is what the meaning is. Okay, converse need not be true, so keep this thing in mind, very important. Okay, so this is what conjugate surds is. Okay, thank you.